Good afternoon, everyone. My name is Caitlyn Wininger, and I'm with Herzig Engineering. I'm a certified electrical safety compliance professional with NFPA, so if you have any questions throughout this free training, please don't hesitate to ask. There is a question feature in GoToWebinar, so please pull that up, get familiar with it, and be ready to ask any questions or provide any comments that you'd like throughout this training. I am going to be watching it as we go, so if I see something come up and it's relevant to the topic at hand, I'll go ahead and address it, or if there's a topic coming up or I think it's better to save to the end, I will just kind of roll with it as we go. Today we're going to be talking about engineer-assisted arc flash studies, talking through the different options there. Now, just real brief, I want to make sure we understand what the topic means, what the title means. So a lot of times, whenever we have arc flash studies performed, or we talk about arc flash studies, it's contracted out to someone who's considered a specialist or an expert in the field, which is great, that's fine. Some people would like to do parts of that in-house though, but still be assisted or oversought by a professional engineer in this field. So that's really what we're talking about today. The differences between having someone do it for you, like Herzig Engineering, start to finish, or partnering with people like Herzig Engineering to provide the assistance and the support and the actual analysis part while you do some of the work in-house. So we'll go through those options. I just wanted to make sure everyone was clear what to expect today. One thing to note before we get too far, we do have a whole bunch of previous free trainings recorded and put on YouTube. So look for the Herzig Engineering YouTube channel, free electrical safety trainings playlists from our live webinars. You can also just download the handout from GoToWebinar and click any of the links that you see in the slides today. So you should be able to get a copy of that handout in GoTo. All right, so first up, we're going to cover what the arc flash study requirements actually are. How do we get one done? Then we'll compare and contrast turnkey solutions versus engineer-assisted or oversaw. Then we'll go into the details about, well, how do you decide what's the best option for you? A lot of it has to do with who you have available on site. And then, of course, we have questions and discussions throughout, but if we have any extra time, we'll dedicate it to rapid fire answering those questions for you. Let's dive right into the overview of what is actually required for an arc flash study. As a real brief reminder, we care about this because an arc flash can happen for a lot of different reasons, a lot of times unexpectedly, usually, unless you're in a lab facility trying to cause an arc flash. But usually, it's a three-phase system, sometimes single phase, depends on the environment, where something's gotten into the circuit, a critter or a tool, something's degraded, something's falling apart or overheated, dust, all kinds of things, causes arc over between the conductors, and then we have a whole laundry list of hazards that result. The flash itself and the heat, the molten material, vaporized material, pressure and sound waves. I mean, this is an incredible event in a horrific way. So because of that, it is vital to predict and protect from these events. So predict the severity of that potential arc flash and protect from those life-changing or potentially fatal injuries that can result. So OSHA does have arc flash hazard guidance documents that they have produced. There's actually 4 different documents. If you go to the handouts tab, I've gone ahead and just put them there for you. Again, you could just go to OSHA's website and download them directly. There's some additional information on that link's website as well, so I still recommend going and looking there. But just to save you a little time, I went ahead and downloaded and put them in the handouts tab in GoToWebinar along with this slide deck, so you can get it all in one place. But basically, it points to the NFPA 70E. Go figure, right? So OSHA and NFPA 70E, the NFPA standards, do have a good working relationship. A quote from that OSHA website basically just says that, yes, 70E was developed at OSHA's request and it helps employees stay safe from these recognized hazards, and following the 70E gets you in compliance with OSHA's electrical standards. Okay, I'm paraphrasing here. The quote's right there on the screen. Again, you can go to the website. But it is required to address arc flash hazards. The 70E tells you how. So for those arc flash risk assessments, there's a few ways to determine the severity of the hazard, and that can be looked at through the equipment labeling as well. A good summary here is including, well, what is needing an arc flash study? Anything likely to require examination, adjustment, servicing, or maintenance while energized shall be marked with a label containing the voltage, the arc flash boundary, and some way for workers to know how to protect themselves against the arc flash hazards. We always highly recommend the full and complete arc flash analysis using the incident energy calculations method. It is the more complete, more accurate, robust method over the last 25 years of doing these analysis. Herzig Engineering is very consistent in saying, do the most accurate study. So that's the incident energy analysis. Now, incident energy and the incident energy analysis, something to point out is the definition of them. So incident energy is expressed in calories per centimeter squared. So it's the amount of thermal energy impressed on a surface a certain distance from the source. For low voltage equipment, that's typically 18 inches. And then it's generated, of course, during an electric arc event. So if there's that flashover, if it's ionizing the air and creating that massive and traumatic event, if there is an arc flash, we can measure that or predict that in calories per centimeter squared. Just a little tidbit there. The incident energy analysis is a way of predicting that arc flash severity. So it's a component of arc flash risk assessments used to predict the incident energy of an arc flash for a very specified set of conditions. Specified set of conditions. I'm going to circle back on that a couple times because as soon as those conditions have changed, you got to have that study reviewed and re-updated. Incident energy is generally calculated using the IEEE 1584 Guide for Performing Arc Flash Hazard Calculations, and there's the 2018 edition that came out. So certainly if it's been since before 2018, you for sure need to get it updated because there's actually better, more robust, more accurate calculations out there now based on more data, more test results from actually having arc flash events calculated versus tested in a lab to see how close those calculations are. So this is a lot closer. It's supposed to be updated every 5 years anyway, but there's just a little extra incentive in case you haven't been keeping up with that. The calculations have changed. So the data does need to be reviewed for accuracy at intervals not to exceed 5 years. Those labels, the study itself, make sure that it actually still applies at a minimum every 5 years. Because, again, it's based on a specified set of conditions whenever you calculate that hazard. So anytime you have new installation or system modification, or you have data verification needed for generation and transmission stuff, that's going to impact the study. If you have a change in utility source, different utility transformer, or they've done some work on the overhead lines, they've done some different stuff, different configurations, that could impact some things. Certainly system impedance configuration or loading. So you've re-ran equipment, you've added a new line, you've changed out the breaker types or the fuse types or whatever. Even things like that impact the study. Okay, so I'm just giving you an overall requirements look at arc flash analysis. So that's the stuff from the 70E. So how do we get these things done? Well, there's two main buckets we're going to look at today. And we're going to compare, like I said, the turnkey solutions where someone just comes in and takes care of everything start to finish, you don't have to worry about it, or engineer-assisted studies. Okay, but the easy way to get through this is just to explain what a typical arc flash study process looks like. So the turnkey process has essentially 6 steps. Okay, it's going on site, we collect the data, we bring it back to the office, the engineers look at it and provide a report. There's a review with the client, we prepare the labels in-house, we ship the labels out and send our guy back to apply those labels. And once everything's confirmed and done and field verified, we create that final study, that final report with the engineer stamping and signing on it, a licensed professional engineer. Okay, so that's the 2,000-foot view of it. But let's get into some of the details here. So that's step 1, would be having a qualified electrician, usually at least master or journeyman or master's electrician, most of them are masters, or a licensed engineer going on site to gather the data from your facility. That's going to be collected in a format that's easy for us to enter into a computer program like SKM Power Tools. So there's a whole bunch of information involved with this, and they can write it out in a very specific way so that we can easily transfer it into that computer program. So this information does require us to access the electrical equipment, but we do not have to shut it down. It does not have to be powered off. You don't have to have a down week for us to come out and do this. Our qualified and responsible electricians can gather this detailed data with a without a single interruption to your operations. We do it all the time. That's what they're qualified for. That's what they're trained for. We have a very rigorous process for teaching these individuals how to do this data collection safely. So overall, the items that they're looking at are impedance elements, so wires, for example, the energy sources, generators versus utility, protective devices, breakers, relays, fuses, other elements like VFDs and motors and transformers and all the things that are going to be included in that engineering analysis. I'll have a little bit more detail, a little more breakdown on what all is collected whenever we get to the other side, because I want you to know, well, what would your people be expected to collect? But right now, we're talking about the stuff you don't have to worry about because we're dealing with it. It's our turnkey solution. I'm just saying there's a lot that goes into it. Then it gets brought back to the office, and the engineers will use that field collected data to model the distribution system on a one-line diagram. And then they'll run the calculations for short circuit and arc flash calculations. We'll look at mitigating the hazards, looking at your equipment ratings themselves. If there was a fault, would it even stand up to that available fault current? And protective device coordination. Will things actually operate in the order that they're supposed to? That is also a requirement to be done every 5 years at a minimum. So we're getting two studies done at once, actually multiple studies done at once, but it's all in one report. Of course, the main goal is that arc flash hazard calculation. So like I said, we'll create a one-line diagram from this. This is a pretty typical engineering process. You get the data, you put it in the program, and you put it out in an electrical line diagram. And you would get copies of these as well. We'll send them out in email for review and things like that. Part of that report, aside from just getting the diagram and the results of the calculations, which also are included right there on the diagram, there's different reports and things, and some recommendations. So one of the benefits of having a professional engineer that really knows what they're doing perform the actual calculations is that we can also provide recommendations to lower the hazards. There are a lot of really simple ways that can lower the arc flash hazards drastically. So careful analysis of those overcurrent protective devices, your fuses and your breaker settings can often lead to pretty simple adjustments to lower those arc flash hazard results. I would not recommend going around and trying to just do it yourself and trial and error. It is very fine-tuned, very specific detail that they're looking at whenever they perform these mitigation recommendation reports, and coordination as well. It all goes hand in hand, but that's part of it. All right, so once that is compiled into an engineering report for you, we'll send it over and have a client review, making sure that nothing's changed from the time the data was collected to now. We'll verify anything that might need double checking, things like that. There's also a chance at this step to look over those recommendations, the mitigation to lower the hazards or the protective device coordination to make sure it's all tripping in order, and decide if you're going to implement those recommendations. So you'll be given an opportunity to accept or put on hold any of those recommendations. If you accept it, if you confirm that it's going to happen, we'll move forward updating the study accordingly and printing labels with the lower hazard ratings. We have to get confirmation though. We're not going to assume that you swapped out a breaker setting or a fuse type. We need confirmation, right? Because we want to make sure that it's a real label. But there's a chance to at least review that and decide. Then we go ahead and prepare those labels in-house. So the engineering team does create those labels that are sufficient for durability for the environment. We say that they need to be updated every 5 years. We typically just replace them all every 5 years, but really you don't have to if the data on the label is still the same. We've gone out to places and like on a rooftop unit, direct sunlight, rain, wind all the time, and 7, 8, 10 years later, you can still read all the information on the label, right? So it works. It'll be more than durable, and we do have some quality checks internally to make sure that it's all printed right and all that's good stuff. So the update and the replacing of labels is more just for making sure the dates all match. Anyway, so this will help make sure the labels are on the right pieces of equipment. So our guys would actually go out with these labels and apply them on site. I'm kind of combining the two steps. So we prepare them, we ship them, and a guy comes back out, or gal. And that's going to be the part that ties all of this together. So this provides the information on how to be safe from the electrical hazards. We do have a pretty rigorous process to make sure that they're applied to the right piece of equipment. The last thing we want is to accidentally put a label for a lower arc flash hazard than what's actually present on that equipment. So we cross-reference with the one-line diagram and reports every step of the way to make sure that they're being applied correctly and consistently. This is kind of a big deal. So whenever I talk about this for engineer-assisted versions, where maybe you guys are going to be doing this, I'm going to have some pretty specific emphasis on this. So those labels go on everything that was included in the study, basically. So the panel board, the disconnect switches, all of those throughout your facility, switch gear, switchboards. There's usually a label per section for those, so you have to be careful about where those go. Motor control centers, we put several labels, one per column, just to make sure that it's easy to find. Could be at the top, could be on the wireways. That's kind of a judgment call for you guys to make. And then overhead equipment. So if needed, we also do larger labels that can be hung or attached to the overhead bus ducts. And then that way they are easier to read from the ground. So that's a little bit of a nuance. We can be able to do that. And usually we don't need a lift either. It's easier if you have somebody who can drive a lift and go and put them up where our guy tells them to. But otherwise we have some tips and tricks to make that work. Once the label application is complete, we have that finalized study. So the label application, whenever it's done by us, kind of is another quality control check as well. Because from the time data is collected and we send the report, print the labels and get back out on site, there could be some time in between. Something could have changed. And so with that process, as they're labeling, they're also double checking that everything is still the same as originally collected. So if there are any changes, we'll go ahead and reflect that in the finished study and send any couple labels that are left if needed. A lot of times there's not, but it's better to just go ahead and have that final check. This is the one that's going to be stamped and signed by that professional engineer, licensed engineer in your state. Okay, so that arc flash study deliverable is going to have, of course, the one-line diagrams. You're going to have those labels applied. There's going to be great reports telling you what everything is and how it was calculated and what recommendations there are, and a lot of good detail for your facility management and engineering team. All right. So that is a good summary of the overall arc flash analysis process. One thing I will note is that with our studies, we also do a complimentary 4-hour electrical safety training just to get everybody up to speed, if nothing else, to make sure you know how to use all the little pieces of information on the label. And that's included in either option, but of course, if we're not going on site, then it's only going to be a virtual option there. Now let's compare that to the engineer-assisted versions, where you're going to be doing some of the work in-house. And Dana, I do see your question. I'm going to circle back on that in just a moment. So for an engineer-assisted arc flash analysis process, you notice some things kind of shifted around, and then there's two main buckets that say in-house instead of us coming on site. So the in-house system data collection, then the data comes to us and we go through the process of creating those reports and having the review. Once we have that review, we go ahead and finalize and print the labels, and then send the labels for you to apply in-house. And somewhere along that process, you'd get a link to a video or a webinar for electrical safety training as well. Okay, so what are the key differences here? Well, you're going to have people who are qualified and able to collect this data and then go back and apply the labels. So what about this data collection thing? Well, your own qualified electrician or engineer would need to gather that data so that we can then perform the calculations. You have to be very careful here. Only truly qualified workers per the NFPA 70E should be allowed to gather this data. It does require accessing hazardous electrical enclosures. You don't have to collect this data while it's energized. It's not like an infrared scan, right? You're looking at it, you're writing it all down. If you have one-line diagrams and as-built drawings and things like that, that's great. Usually it doesn't include everything we need though, so we still have some gaps where they need to write some stuff down and take some pictures with the covers off. If you do decide to do it during a shutdown week and everything's been verified off, You still have to have a qualified person do that step. You still have to have them verify that it's off. So again, don't just throw anybody on this task because they have time. It needs to be someone who's truly qualified and knows a lot of detail about your electrical distribution system. Probably your highest qualified person is going to have to be dedicated to this. Okay, so the kinds of things that they're going to be collecting. Like I said, the impedance elements, the energy sources, such and so forth. So wires and cables, reactors and inductors for filters and drives, transformers, we need the nameplate info, so the kVA, the voltages, is it stepped up, stepped down, is it an isolation or buck boost transformer, what's the percent impedance for that, the percent Z. For the wires, how long are they, how many per phase, what type of wire is it aluminum, is it copper, is it 500 kc mil, is it 4-aught, what is it? All of that needs to be included in the data, as well as those energy sources. So utility fault currents, whether it be the MVA or kVA, the voltage, is it 3-phase, line to ground, what are the XR over R ratios? If you have that information, motor nameplate info, voltage, horsepower, power factors, generator nameplate, kind of same ideas here with renewable sources, all that energy that could get inputted into the system. Protective devices are a big part of it, and a lot of times people are like, oh yeah, we have this whole row of 200 amp breakers for this equipment, and it's like, I need the model, I need to know if there's adjustable settings and what every single one of them are set on for every single breaker. We want verification on all of them. For fuses, it's not just, a 200 amp fuse, it's a 200 amp FRSR fuse or an LPSR KSP or whatever. It's like we need all the details for breakers and relays and fuses, all those things. Other elements could be UPSs or soft starts or VFDs, DC drives, things like that. There's some other elements that might come up, and this is where the engineering assisted part comes in, where we could be on call to answer any questions, maybe even do a video chat and say, do I need to collect this? What information do I need? And then we can help guide through that process. But a lot of times, again, you're going to need your most highly qualified person to even know what questions to ask, frankly. So that's the in-house data collection portion that otherwise would have just been taken care of for a consultant coming on site. Then all that data gets sent into the office, we do the reports, we do the preliminary review, we finalize it, we prepare the labels, and then send you those labels to apply. Now that's the last step for this portion. And again, somewhere along the way, you have training. Once the study is complete, the arc flash labels can be self-applied by one of your qualified workers with support from our engineering team. So what does that mean? We're going to be on the phone, maybe setting up a Teams meeting or a Zoom call if needed, right? We're going to help ensure that the labels are applied to the appropriate equipment and be on call to answer any questions. We'll walk through how to read the one-line diagrams and interpret the reports to make sure that they know how to identify the correct enclosure for each label. Okay, this is so critical because whenever you're doing it in-house, misapplied labels can happen. You have to be so careful. If it's misapplied, it can lead to confusion and major safety issues. So for example, and this picture is kind of zoomed out, but it's a good example. There are 3 different label types from 3 different rounds of studies. I understand wanting to save costs and limit site time from an engineering consultant, I get that, but you have to be very careful that whoever is in-house doing that work knows what they're doing and why. Because right here we have, like I said, 3 different label types from 3 different rounds of studies, and they don't match. So if somebody walked up to this piece of equipment, they might be tempted to pick whichever label has the lowest hazard. And that is not the most up-to-date label. That is not the correct label. So, you have to make sure that you verify every single label gets on the correct piece of equipment and you're not leaving old arc flash label information. So either completely remove it or cover it up or exit out or do something to make it clear that that label is not to be used, not to be relied on. Okay, so do not trust just anybody to do this. Don't hand the stack of labels to the new guy and say, have at it, give him a job. No, it needs to be someone that you trust. Okay, now for that labeling practice, it's going to be on the outside, it's going to be eye level. And it should be where we tell you, essentially, match the name to the equipment, such and so forth. For things like automatic transfer switches, and this is coming from a question, where there's a normal and an emergency feed, the labels usually will go on the ATS, and it will mention whether it's from emergency or normal feed. So, or it could be directly downstream of the ATS. It depends on how it's all set up, manual transfer switch or automatic transfer switches, where that label needs to be. So usually it'll have the name and then N for normal, or a second copy with E for emergency, or however that terminology makes sense for you guys. And that would be part of the training as well. But they usually go side by side unless you've decided to do just the worst case. Sometimes it's the normal, sometimes it's the emergency, and then we only send you the one that is the most conservative to, again, avoid any confusion. So that's an option to discuss as needed. So how do you decide what's best for you and your team? Well, first off, do you have a highly qualified electrical personnel on staff? You know, multiple preferred, but at least one guy or gal that you really trust, that knows your system and is able to do all of the arc flash study, data collection, and label application effectively, consistently. The second question is, are they able to dedicate that time to it? It is time consuming, so can they? Do they have too much to do, or is this something that can be budgeted into their schedule? Is there another in-person or in-house person that can confidently verify the label application process? Did they get it on the right pieces of equipment? Ideally, this is a second person, especially if you're not hiring it out, right? So if you have it done in-house, cross-reference, verify, double-check people's work, right? That's only a best practice. So, turnkey arc flash studies versus engineer-assisted arc flash studies. What's the difference? Biggest difference, the turnkey solution offers a hands-off approach completed by experts in the field. So we'll take care of the study start to finish, no operation interruptions, no worry, no hassle. There is a little bit more investment with that because of the amount of time, the travel costs, the on-site time, things like that. Then there's the engineering-assisted study. So it can have some cost-saving properties. You know, you have less travel or no travel time for us, less time consulting with our specialists, no on-site time there. So that can be a cost savings. It does require you to have properly qualified electrical and personnel that are available. It can be time consuming. It's a highly detailed process, especially since they're not used to doing this work. It could actually take them longer than what our guys would take, just because, again, they're getting used to, well, what all am I actually looking for? It seems straightforward, but then you get into it and it's like, oh, there's a lot to take pictures of or write down or whatever. This method also requires in-house qualified personnel to apply the labels, and ideally a second to verify that it's done properly, doing a cross-reference, a cross-check. But yes, it can help save some costs. And if you have the right people, by all means, why not let them get involved? Have that buy-in, let them be part of the process. It could even impact your electrical safety culture in a drastic and positive way if people are taking ownership of it in this way. I'm just being very careful to say, be cautious. Make sure it's the right people. And if you're not sure that they can handle it or they don't have the time to, don't be trying to cut corners on this stuff, okay? Of course, if you need some help, we do have options for both scenarios there. We've been doing this for 25 plus years. We're licensed nationwide. We've done this a lot. You know the spiel by this point. We're PE reviewed reports. You got field collected data by licensed electricians and engineers, or those engineering assisted arc flash study options. We provide those mitigation strategies and coordination recommendations, lower the incident energy levels, improve your system performance. We also have a portal, so your projects would end up, you know, the one-line diagrams and reports all in one centralized place, which is especially great if you have multiple facilities, multiple sites that you have to deal with. So that way it's all, you know, kept in one place for you. So there's our overall understanding of what the arc flash hazard process requires, the arc flash study process, the difference between turnkey solutions versus engineering assisted, where you get to do some of the work, and some factors on how to decide what's best for you. Little note here before we jump into some of the questions that have been coming in. I will say we did a full hour-long webinar on the arc flash study process and some ways that we would recommend lowering the hazards. So if you want more detail about the data collection process and the label application process to decide if that engineering assisted route is best for you, or maybe get that insight to tell you it's better to just let the experts deal with it, go watch that one. Again, more detail on the actual process there than I had time for today. All right, with that, I do have some questions here that I'm going to get into. If you haven't yet and you would like to, go ahead and go to the question feature in GoToWebinar, submit your question, comment, concern, feedback, story, whatever, preferably questions at this moment, but I'll read through them all, and I'll be happy to answer them. Otherwise, if you need to hop off here, because I know it's right at the top of the hour, the webinar is technically supposed to be over, you can always email me, cwininger@herzigengineering.com, or just call the office, ask for Caitlyn, and they will know who to get you to, because I'm the only Caitlyn here. Awesome. With that, let's go to the questions. So is arc flash calculation required for a sealed maintenance-free equipment needing no maintenance? Ooh, okay. So the mentioned equipment is fed with 480 volt three-phase power. Sealed maintenance-free equipment needing no maintenance. I'm very shocked that there could be such a thing. A piece of electrical equipment that needs no maintenance. I mean, that's just futuristic sci-fi movie stuff to me. I'd be curious to know a little more detail there. I'd be surprised, I will say. If that's legit, if there's just no need for maintenance ever, technically no, because the NFPA 70E says anything likely to require examination, adjustment, servicing, or maintenance, right, while energized. And you have to act like it's energized until you verify it's off. So if you're really never ever going to get into it while it's on, that element right there maybe does not need a label. Again, I'd be very, very surprised if that was the case, because if nothing else, tightening connections and things like that, stuff loosens up. Even in a quiet office environment, the electricity, there's going to be some vibration, so the stuff loosens up. Again, I'd be curious to know more. All right, follow up here. So if the employer has a policy and program in place to not work on energized equipment, would they be able to argue that they don't need to have an arc flash calculation done for their equipment? No. Absolutely not, because you have to be able to verify that the equipment is off before you take off the PPE or be able to take down the boundaries. So even just open it up and look at it, even if you're just going to get a voltage measurement, so energized because you're troubleshooting, so it is energized work. Bare minimum, you have to open it up to verify that it's off with your meter. Only qualified persons with proper protection are allowed to do that. You cannot skip an arc flash calculation just because you don't work energized. By the way, nobody should be working energized. Put those insulated tools away, except for worst case scenario or as a backup, but stop servicing, adjusting, and replacing stuff while it's energized. 99.999% of the time, you can turn it off. You just don't want to jump through the hoops to do it. But it's definitely a priority to turn it off. So definitely still need to have the study to make sure that you're safe during that process. Bryce has asked if we can get a recording of this. Yes, so every single one of our webinars is recorded, and in the follow-up email, you're going to be able to get access to that. We also have posted all of our previous webinars on our YouTube channel. So if you go to download this handout, you can click on that link directly. Otherwise, you can look up Herzig Engineering on YouTube and go back and watch all of the webinars, including this one, which will be posted later today or tomorrow, depends on how many emails I get after this. But yes, the recording is always available. Maintenance-free UPSs is an example. Okay, I could see that maybe. Talking about that question earlier. Do we need to make arc flash study for DC systems or battery banks? Possibly. Possibly, yes. There are calculations for DC systems. Batteries are getting a lot of attention recently. So depending on the size and how it's configured, the answer could be yes, absolutely. Arc flash does happen in the DC world as well. Okay. Let's see here. So have a comment here that turnkey study is the preference with someone such as themselves. Lots of experience tagging along to assist. That's phenomenal. Yeah, anytime, even with a turnkey quote unquote solution, if there's someone on site that is knowledgeable that can escort and kind of show around, not necessarily have to do the work themselves, but be there to answer questions and things, that makes the process go a lot smoother. Let's see. And it is a great learning opportunity as well. Got a question, incident energy and PPE category in the same arc flash labels. So no, because if you're going off of the PPE category tables, it's a different arc flash analysis process than incident energy. So technically, no, you can't have them both listed. And the reason for that is because sometimes one will be lower than the other, and you need to have a consistent analysis process throughout your facility. So if it says PPE category and an incident energy analysis result, there's some questions there. If it says PPE level, like a site-specific PPE level that is an easy check for those workers as part of their safety program, that's a little different. A lot of companies will define their own site-specific PPE level, and then they put together kits, or they put the PPE level based on the qualification level, things like that. That's okay, that's acceptable, but it's still based off only one of the analysis methods to get the result of that hazard level. I hope that makes sense. All right, any other questions? Please feel free to pop them in that question feature. Again, otherwise you can email it to me or call the office. I'm more than happy to help. If there is not anything else today, I just want to say thank you so much, guys, for jumping on here and being so engaged and informative. I hope this was an informative webinar, but engaged in talking about your experiences as well. Really appreciate it.